When you think about these problems, it actually is pretty important to try to get the terminology right for various kinds of reasons. So this is a second order equation because it involves a second derivative and not anything higher. It's also linear because it doesn't, for example, involve y prime squared or square root of y or anything like that. It doesn't matter that the t squared is nonlinear. That doesn't affect the linearity of the equation. In effect, the left-hand side is a linear transformation. That's the key thing about the linearity. It is non-homogeneous now. So far, we've always had zeros on the right side. Now we've got something non-zero. There is a forcing function that is t squared in this case. You're going to have a problem or two where you have to deal with an exponential decay there. And then in section 4.2, the most realistic kind of situation is when that's a trig function, a cosine or sine of some frequency. But that's also the hardest situation, so we want to deal with easier situations first. To solve this, it's very similar to first order equations in chapter 1, first order linear equations. You want to consider the associated homogeneous equation where you get rid of the forcing function, y double prime plus 5y prime plus 6y equals 0, because we know how to handle that kind of equation. First of all, that's one reason to consider it. Another reason is because this is linear, when we find our particular solution to this and add a general solution to this, that will be then a general solution of this. It's kind of going back and forth here. We can just look at this and write down what the eigenvalues are. I'm using lambda. Sometimes we use S. This is easily factorable as lambda plus 3 times lambda plus 2. And the eigenvalues are -3 and -2. So your general solution then, which you could call y sub h to emphasize it's a general solution of the homogeneous equation, arbitrary constant e to the -3t plus another arbitrary constant e to the -2t. No need to convert to a matrix vector form, though we could. We could introduce the velocity to be y prime, write down a system, find eigenvalues. You would get -3 and -2 for the eigenvalues. For eigenvectors, you'd have to either deal with the matrix, or if you've got the scalar form, you could differentiate it to find the velocity and write things in terms of vectors to find the eigenvectors that way. All right, so that's a general solution of the associated homogeneous equation. But then there's the method of undetermined coefficients. Kind of just a fancy way of saying educated guessing. Though there's a reason for calling it undetermined coefficients, is because you have to solve for some undetermined coefficients as well. You guess yp, a particular solution of the non-homogeneous equation, based on the form of the right-hand side. Thinking of the left-hand side as the linear operator, we're asking what kinds of functions can I plug into that? Take the second derivative, add 5 times the first derivative, add 6 times the function, and get t squared, no matter what t is. You don't want to guess a trig function. You don't want to guess exponential. It makes sense to guess a polynomial, and it turns out to be good enough to use a degree equal to the degree of the right-hand side. You may not know that ahead of time, but that turns out to be good enough, and you can check it by actually plugging it in. Take the derivatives, plug them in the left-hand side of the differential equation. So compute yp double prime plus 5yp prime plus 6yp. It'll be 2a plus 5 times this will be 10at plus 10b, and then plus 6 times this will be plus 6at squared plus 6bt plus 6c. Question? Yes, thank you. 5 there. Mistake. Thanks for catching that. Set this equal to the right-hand side, t squared. You want this to be equal no matter what t is. The only way that's going to happen is if the coefficients of t squared t and the constant term match the coefficients over here, which would be 1, 0, and 0. The t squared term over here has a coefficient of 6a. The t term has a coefficient of 10a plus 6b. And the constant term has is 2a plus 5b plus 6c. Again, this is supposed to be equal to t squared for all t. That's important to realize, not just particular values of t, but for all t. And the only way that's going to happen is if 6a equals 1, coefficient of t squared is 1, and then these other things are 0. 10a plus 6b equals 0, 2a plus 5b plus 6c equals 0. You can maybe rearrange these, put these in a matrix. It would be upper triangular. But you can just solve these pretty quickly. A is going to be 1/6. Substitute that in here. B is negative 10/6 A, right? Or negative 5/3 A. Substitute in 1/6, that's going to become a negative 5/18. Right? Look good? C, solving this last equation for C in terms of A and B is going to be negative 2/6 A minus 5/6 B. Of course, that's also a negative 1/3. So we get negative 1/3 times A minus 5/6 times B. Negative 1/18 plus 25 over what? 108, is that right? Let's see, does 18 go into 108? Yes, it does. 6 times. This is negative 6 plus 25 over 108. I've not made a mistake. 19 over 108, is that good? Yeah, there's a lot of work in this, but it's still fairly straightforward. So YP is going to be, A was 1/6, 1/6 t squared. B was negative 5/18. That gets multiplied by t, and then your constant term is 19 over 108. Not done. That's just YP. Now we need a general solution of the original homogeneous equation. General solution of the original. Y is YH plus YP. So that'll be K1 e to the negative 3t plus K2 e to the negative 2t plus 1/6 t squared minus 5/18 t plus 19 over 108. We'll need the derivative of that. Here we go. And then we want to plug in t equals 0 to solve the initial value problem. 1 equals y of 0. Plug in t equals 0 up here. You'll get K1 plus K2 plus 19 over 108. And then 0 is y prime of 0. Negative 3K1 minus 2K2 minus 5/18. Hopefully no mistakes. Get a system of equations in K1 and K2. Maybe I'll use a matrix for that one. K1 plus K2 equals 1 minus 19 over 108. 108 minus 19 is 89. And then the second equation, the coefficients will be negative 3, negative 2, and bring that over to the other side of the positive 5/18. Okay. Do your row reduction. I'll just do this with my calculator now. 1 E9 over 108. I've got mine converted to decimal form, -3, -2, 5/18. Let's see, we need to do RREF. Matrix A. Okay, so K1 is about -1.9259. If you found it as a fraction, great. K2 is 2.75 as a fraction. That would be what, 11 force? 11 force. Does anybody want to tell me what this is as a fraction? -52 over 27. Okay. There we are. Plug those numbers back up in here. And then you're done. And all we're after is a scalar solution, so we'd be done.